Hey guys, this is a quick video to just show you how to multiply binomials with imaginary numbers and irrational numbers. We're still going to use the same area model. You can still use FOIL or distribution, but I want to show you the patterns that arise with imaginary numbers and irrational numbers. So imaginary, I want to remind you, is anything that has an I in it. So here we have imaginary numbers, 5i and negative 5i. As you'll find out in task 3.8, these always come in pairs when we're looking at polynomials. We'll always have the positive version and the negative version. So positive 5i with negative 5i. That means we need to know how to multiply them out. So I'm just going to use the box method or area model, and we're going to look for a pattern. So x plus 5i, x minus 5i. Let's multiply. Top corner is x times x, which is x squared. Multiply down, and this becomes 5ix. Okay, top of the next is x times negative 5i, so negative 5ix. And then the bottom corner is going to be negative 5i squared. So let's first address the fact that positive 5ix cancels out negative 5ix. That's what we wanted. But what's going on in this corner right here? Well, we have negative 5i times positive 5i. And I can kind of break this apart. I can say negative 5 times positive 5 is negative 25. And I times I is I squared. Well, I squared is negative 1. I squared equals negative 1. So this is actually like negative 25 times negative 1, or just a positive 25. So what do we have left over? We have that x squared plus 25. So what I want you to notice is that the center term is completely canceling out. The first term, x squared, the last term, 25, is really like our pattern of difference of squares. But because we had this plus sign here in the middle, we ended up with imaginary factors. So the way I like to think of this is it is a sum of squares, meaning we have something perfectly squared plus something else perfectly squared. And that sum of squares leads us to x plus whatever is square rooted I, x minus whatever is square rooted I. Let me give you one more example of that. And I'm going to make this one a little bit quicker. If I had x minus 2i and x plus 2i, well, if I see that as a sum of squares, I know that I had x squared because that's the first term squared, and 4, because that's that second term 2 squared, but they were added together instead of subtracted. So that is a pattern you don't necessarily have to memorize, but it's nice to recognize. Okay, so that's imaginary numbers. Let's check out irrational numbers now. Irrational numbers are anything with a radical. So you see here we have radical 3, and we have both positive radical 3 and negative radical 3. Just like imaginary numbers, those are also going to come in pairs. So let's use the box method again. Area model or even FOIL would work. Here we have x minus radical 3, x plus radical 3. The top corner is x times x, giving us x squared. Directly down from that, I'll have negative radical 3x. Okay, top of the next column is radical 3 times x, so I have a positive radical 3x. And the bottom corner is negative, I'm going to write this out, radical 3 times radical 3. First thing we notice again is that on the diagonal, the positive radical 3x and negative radical 3 cancel out. That's what we want each time. And let's break down what's going on in that bottom corner now. Negative radical 3 times positive radical 3. Well, radical 3 times radical 3, we can put those both underneath the radical and say it's the square root of 9. Square root of 9 is just 3. So there we have the square root of 3. So if we, again, take inventory of what we have left in the box, we have our x squared and minus 3. So if you want to think of this as a difference of squares, you kind of can. Here we have x squared minus 3. A difference of squares would mean square root the first term, x, square root the second term. Well, the square root of 3 is just the square root of 3. We can't simplify that at all. Subtract 1, add 1. Okay, one more quick example to show you the pattern. If I had x minus radical 7 and x plus radical 7, if I think of this again as a difference of squares, difference meaning subtraction, I could just combine that as x squared, which is the first term squared, minus 7, the second term squared. Again, our difference of squares. Okay, hopefully that helps you guys know how to handle multiplying with binomials whenever there are imaginary numbers or irrational numbers. But please ask a question. Let's practice more of these together.